to all of you. I am Dr. Ritesh Kumar and going to give the presentation on the topic on the subject of communication engineering, and the subject code is KEC 401. So, and the topic name is communication system, modulation and need of modulation. So, in this lecture we will cover the same one here. Now, we will start. This is the syllabus of the subject communication engineering. The code is KEC 401. It consists of 5 units, and first unit mainly covers the DSP, SSV and VSV modulation, and in which we also cover the review of signals and frequency domain representation of the signal as well. In the second unit we will cover the different modulation techniques such as frequency modulation and phase modulation as well. So, in the third unit basically it is related to the random variable and random process. So, in this unit we will cover the same one, and the fourth unit is basically related to the pulse modulation techniques, PCM, and these technique comes under the pulse analog modulations, and the last unit which is related to the purely digital modulation techniques such as PSK, ASK, FSK, etc. So, basically in this subject we will learn how we can communicate the signals through a channel by using modulation and demodulation techniques. So, before starting all the units we need to understand what is the modulation and the utilization of the modulation, what is the purpose of it. So, let's begin. These are the books which has been recommended by the university syllabus, and these are the 7 books. But out of these 7 books, I will recommend the first book is Hyman Hagen. The title of the book is Communication System, and the second book, Torben Schilling book, which and the title of the book is Principle of Communication System. Right? These 2 books are important to cover all the syllabus of this subject. So, please if you have, then well and good. If you don't have, please take it from the library. Now, let's begin with the introduction. What is the communication system? So, as in the first point I have mentioned, it comes from the Latin word communis, which means to share the information. So, communication is nothing but of sharing of information between 2 or more persons, and in other words, in technical point of view, we can say transformation of the information signal from source to destination, also called as communication process. So, if I talk what is the communication? If two person is talking in the same language, then they are able to understand the information comes information from with each other. But if some person is talking in different language which cannot understand by the another one, so there cannot be possible the communication between each other. So, to have a communication, it is necessary the signal should be informative to the other one. So, for this case, we need to have some kind of interpreter in between 2 persons. That is so that communication can be possible. So, we can say communication is nothing but a transformation of informative signal from source to destination or transmitter to receiver as well. So, here we have mentioned the exchange of ideas, information and knowledge by 2 or more persons. So, this is a basic definition of communication. Now, what is the basic building block diagram of the communication system? So, this one is the basic communication system block diagram. If I talk the basic building blocks of the communication system, there would be only 3 blocks. The first one is the transmitter side, second one is the receiver side, and third one is the channel, right? So transmitter side mainly consists of information source, transmitter, transducer, and at the receiver side it consists of receiver, transducer, receiver, and destination as well. And in between these two sides there must be a channel. So channel could be in the form of, in the either form, it could be in the form of wire or wireless. First we talk about first we will talk we will discuss the at the transmitter side. So at the transmitter side the information could be in the form of human voice, picture, code, data, and music. All of these informative signal can be considered in the can be considered as a message signal. So this message signal first first need to convert in the electrical form. So by default these signals is considered in physical signals, right? So these signal can be categorized in the form in the low frequency range, because message signal, or we can say a modulating signal, is a low frequency signal. So so at the transmitter side there must be a kind of transducer would be there, so that this physical signal can be converted into the electrical signal. So electrical signal. So transmitter always consists of a kind of transducer, so that one form of energy, that is physical signal, can be converted into another form of energy, that is electrical signal. Now what is the utilization of doing the modulation here? Because without using the modulation we cannot transmit the data at the longer distance. So if we want to transmit the data at the longer distance, so for it we need to do the modulation at the transmitter side. This is the one main concern to do the modulation process at the transmitter side. Now we will talk about the channel. So channel channel is a media through which the information exchange takes place. So channel could be in the form of wire or wireless. So in the wire category we have a kind of channel such as coaxial cable, uh, twisted pair wire, and optical fiber, and these are the kind of wire these kind of transmission we can use for the wire communication. For the wireless communication we need to have kind of antenna that can be used as a transmitter side, and the same antenna can be used at the receiver side to receive the signal which is transmitted from by the transmitter. So in the case of wireless transmission, what happen at the receiver side? So this electrical signal, first we need to convert this electrical signal into the electromagnetic radiation. So antenna at the receiver side converts the electrical signal into the electromagnetic wave. So we can say antenna is nothing but a kind of transducer which converts the electrical signal into the electromagnetic waves, so that these waves can be transmitted in the free space. So wireless communication, also called as free space communication. What at the receiver side, same antenna can be can be used, because this antenna also converts the electromagnetic waves into the electrical signal, right? So so this at the receiver side, the antenna do the just opposite operation which have a it has done at the receiver side, at the transmitter side, sorry. Now because at the channel you can see the noise source, so in the propagation there would be there must be a kind of noise is there, noise always be there, because some kind of interference in the free space would happen in which collides with the message signal, and these signals disturb the message or it reduces the SNR as well. So SNR is a signal to noise ratio, means SNR SNR is nothing but is the ratio of signal power to the noise power. So noise always degrades the performance of the channel. So our aim is always be to reduce the noise as low as possible. So but noise but the deletion of the noise cannot be possible from the channel. Now at the receiver side, whatever you have done at the transmitter side, just do the opposite operation at the receiver side. So at the transmitter side we are doing the modulation, then for at the receiver side we will do the demodulation process. So demodulation process is nothing but to fetch or to get the original signal from the modulated signal. So this is the modulation process at the receiver side, and because we are receiving the electrical signal either from the wire media or wireless media. So this electrical signal has to be converted into the physical signal, and that could be possible with the help of receiver transducer which inbuilt into the receiver, and that signal mm, and the same signal, the same physical signal which we have at the transmitter side will get at the destination or will reach at the destination. So this is the basic communication system block diagram that we have here. So I think this one is clear to all of you. So in brief I can again tell you, first it converts at the receiver side the main voice signal or main message signal converts the physical signal convert into the electrical signal, then at the receiver side this electrical signal into convert into the physical signal, that is the main message signal. So I think this block diagram is clear to all of you. Next, explanation of communication system. All of the things I already discussed in the previous block diagram, that is information source. So so information could be in the form of voice, picture, code, data, music, and a combination of these signal as well. Transmitter and channel and medium. So channel is the medium by which the electronic signal is transmitted from one place to another. So for the wire transmission, it could be a conducting wire, coaxial cable, optical fiber cable, and for the wireless communication it would be free space. So all of the things I have already discussed in the previous slide. Noise, receiver, and destination. Next one is the terminology used in the communication system. So here I am talking about the terminology. So what the terminology we will use in the future lectures. So first we need to understand what is the baseband signal, broadband signal, modulation, demodulation, massive signal, carrier signal, and modulated signal. So all of these terms are necessary to understand what it is. So baseband signal. So here in the previous PPT, in the we have mentioned the message signal or information signal. So message signal is nothing but a baseband signal, or in other terms we can say it is a modulating signal. So here we have mentioned message signal also called as baseband signal and modulating signal, also called as modulating signal and or message signal, right. So broadband signal, broadband signal, the broadband signal in the modulated frequency range is known as broadband signal. Mean after modulation, the signal which we have got is known as broadband signal. In other terminology, we can say it is a modulated signal as well. So at the receiver, at the after modulation process, the signal which we have received is known as modulated signal or broadband signal, or in other terms we can say passband signal as well. So this is another term which we need to understand what is the broadband signal. I think this one is this one clear to all of you. Modulation. So modulation is a process which converts the low frequency signal into the high frequency signal, right. Modulation always convert low frequency signal into the high frequency signal, right. So low frequency signal known as the message signal and high frequency signal is known as broadband signal or modulated signal. So we have different kind of definition of the modulation. First one is it converts the low frequency signal into the high frequency signal. It converts the baseband signal into the passband signal or broadband signal or modulated signal as well, or it converts the modulating signal into the modulated signal as well. So different kind of modulation definition we have. So basically modulation always be used for the long distance communication. For an example, suppose if I move from Delhi to Agra in UP, so by walking it cannot be possible to reach fast, or if I move from Delhi to Agra, then my energy will get down. So for for reaching faster from Delhi to Agra, we need to take the help or we need to take help of vehicle. So with the help of vehicle we can reach there fast as compared to by walking. So here we have modulated our speed by using the vehicle, and we instruct the vehicle moving direction of the vehicle. Either you can make it left, right, and straight forward. So you are giving the direction to move from Delhi to Agra. So actually you are giving the message uh, to the vehicle. So by with the help of vehicle you can reach there faster. So the same process you are doing here. With the help of carrier signal, high frequency signal, you can modulate modulate it with the help of message signal, and you can convert this low frequency signal into the high frequency signal, and with the help of this modulation technique it is possible to have a long distance communication. So this is the basic principle behind the modulation technique. And the demodulation is just the opposite, or opposite of it is just the opposite process of the modulation, by which the baseband signal and the carrier signal are separated from the modulated signal, is called demodulation. So with the help of demodulation, you can get the actual signal, that is the actual physical signal, by separating from the carrier signal. The message signal is a modulated signal, as I discussed already in the previous slide. Carrier signal is a high frequency signal, right? High frequency signal. And modulated signal is the signal after having the modulation process. So it is a combination of carrier signal and the message signal. So this is a modulated signal. I think this actually these all the terms you have to understand, because all of these terms will use in the future lectures. So I think these terminology are clear to all of you. Next, modulation and need of modulation. So as I discussed, modulation is the process that converts baseband signal into the passband signal, low frequency signal into the high frequency signal as well, right? So it converts baseband signal into the passband signal, as I discussed in the previous slide. So here in the first one I clearly mentioned here. Second point, it is already discussed in the previous slide. So the main topic is the need of the modulation. So advantage or need of the modulation, we will discuss one by one separately. So before starting the advantage or need of modulation, what is the original signal? Or original signal is the baseband signal, or we can say it is a message signal as well. So need of modulation, the first one, it reduces the height of the antenna, increases the range of communication, avoid mixing of signals, allows multiplexing of signals, improves the quality of reception. So superficially I can tell you here, by increasing the frequency of the signal, we have all these kind of advantages which have written over here. So one by one we will discuss in the next slide. Reduces the height of the antenna. So as we know, the height of the antenna always be in the terms of the wavelength, right? Because wavelength is related to the frequency, and an antenna always work a particular resonating frequency, because antenna has its own resonating frequency. So with the help of resonating frequency, we are able to find the operating wavelength as well. So in terms of wavelength, we always define the antenna height in terms of wavelength, right? So in the standardized format, we use the dipole antenna or monopole antenna. So here we are talking about the monopole antenna, and monopole antenna has the height of lambda by 4, right? So lambda by, as we know, the lambda wavelength is c by f, and lambda is inversely proportional to the resonating frequency, right? In terms of height, we can say height of the antenna, or transmitting antenna or receiving antenna, is inversely proportional to the frequency. So if frequency increases, height of the antenna will decrease. If frequency increases, height of the antenna will decrease. If frequency decreases, height of the antenna will increase, right? So our aim is to have the height of the antenna as low as possible. For it, we need to increase the frequency of the signal, and for it we need to do the modulation process, right, as we discussed in the previous slide. Now lambda is equal to c by a, where c is the speed of light. If we talk about if we transmit our signal frequency, message signal frequency to 2 kilohertz, that is low frequency signal, right, 2 kilohertz, then corresponding to this frequency, if we calculate the height of the antenna, it would become 37.5 kilometer, right, by putting this frequency in this equation, right, clear. Now 37.5 kilometer is a very very large huge height, so practically it cannot be possible to have this much height of the antenna. Now how it can reduce? By increasing the frequency of the antenna. If we talk about, if the signal frequency 2 kilohertz, if the signal frequency is 2 kilohertz, then corresponding to this 2 megahertz, sorry, so corresponding to 2 megahertz, right, the height of the antenna would become 37.5 meter, and this is in kilometer and this one is the meter. So practically it could be it can be possible to have this much height of the antenna, and reduction of the height would, here the reduction of the height is achieved. Now so one advantage of doing the modulation, it reduces the height of the antenna, so it is the most important advantage of the modulation process, right. I think this one is clear. Next, need of modulation. So increases the range of communication, as we have already discussed in the last slide, in the starting slide, that avoid of mixing of signal. So here you can see the signal frequency is same here in all the cases, and by using the different carrier frequency we can transmit these signal at different frequencies, so that all these signal cannot be interfered with each other. This is the another advantage of the modulation process. Next one is the allows multiplexing signal. So with the help of modulation or with the help of different carrier frequency, we can transmit multiple number of signal over a single channel. So it could be possible with the help of the modulation process only. Next, need of modulation, improve the quality of reception. So with the help of high frequency signal, we can improve the SNR, and by improving the SNR, the signal quality will improve. This is a spectrum, EM spectrum. So this is the range of frequency which we have mentioned over, different kind of bands we have mentioned over here. So this is, I think this all clear to all of you. So thank you everyone.